Let us now start off with the very important form of old classification of elements, and that is Mendeleev's periodic table, right? Now, after 5 years of Newland's law of octaves, there was a Russian chemist named Dmitri Mendeleev. Dmitri Mendeleev, he was a Russian chemist and he published a periodic table. He published a periodic table. Okay, periodic table. And this table had many advantages, many achievements. As compared to other forms of classification, the flaws in this table were very less. And if you see, to a large extent, it was a very successful table, right? Now, what was this table and how did it work? That's what we're going to study now. Mendeleev formulated a table based on a law he had prepared, right? He prepared a law, and that was known as Mendeleev's periodic law. Mendeleev's periodic law. Okay. He prepared his table based on this law. Now, what does this law state? The statement of this law is important. Please pay attention. Now, Mendeleev's periodic law states that properties of elements are a periodic function of their atomic masses. Now, I hope you understand this law. Basically, it means to say that the properties of all elements, are a periodic function of their atomic masses. That is, they keep repeating. They are repetitive with respect to the atomic mass, right? They occur in a cyclic form, repeating form with respect to their atomic mass. This is called Mendeleev's periodic law. Okay, so this was the law on which Mendeleev based the formulation of his periodic table, right? This was one thing. This was one basis. Another thing was, he took elements, right, and he formulated general forms of oxides and hydrides. Okay, he developed general forms of oxides and hydrides of elements. He made a general form for oxides and hydrides of different elements. Okay, a general form of different elements which had similar properties, right? And he put similar elements based on the periodicity of their properties into groups, that is vertical columns and periods, that is rows. So he arranged elements in vertical columns, that is groups, and rows called periods. Each group had its own unique formula for oxide and hydride. Okay, each group, that is each column, had its own particular formula for an oxide or a hydride, and there were total 8 groups, and each group had 2 subgroups, subgroup A and subgroup B. So each of the 8 groups except for the last group had 2 subgroups, subgroup A and subgroup B, except for the last group, that is the group 8, right? And then it had periods, which were horizontal rows of elements. Okay, so he formulated general forms of oxides and hydrides, and there were 8 groups, and for each group there was a unique form of oxide or hydride, unique formula for oxide or hydride. He arranged them in atomic masses, increasing order of their atomic masses, and he saw that there was a repetition in properties. Okay, so that is what was the basis of Mendeleev's periodic table, oxides and hydrides, as well as the periodic function of atomic masses. Right, so I hope that's absolutely clear. This was an overview of the basis behind Mendeleev's periodic table. Now let's have a look at Mendeleev's periodic table, and here we have Mendeleev's periodic table in front of us. Right, so Mendeleev's periodic table, here we have depicted his table, and let's have a look. Let's try to study this table. Look into the group. Look into these groups. Right, what do you see here? In the labeling of the groups, you can see that there are 8 groups, and you can see that for each group there is a unique form of oxide or hydride. So these are the general formulae of oxides and hydrides. So we formulated general formulas of oxides and hydrides, and you can see for each group there is unique one. For first group there's R2O and RH. For second one it's RO and RH2. For the third one it's R2O3 and RH3. For the fourth one it's RO2 and RH4. For the fifth one it's R2O6 and R2O5 and RH3, I presume. Okay, and for this it's RO3 and RH2. For this is R2O7 and RH, and for the eighth group it is RO4. So we formulated the general formula for oxides and hydrides for each particular group, right? Then you can also see the periods. Here we're going down to the periods. Okay, and those were the groups. These are the groups which go here. And you can see here, then we have arranged the elements. Hydrogen, then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. And you can say that lithium to this silver, right? All this come under group 1. These come under group 2, these come under group 3, group 4, group 5, group 6, group 7, and then group 8, as you can pretty much notice, right? You can also notice one more thing, that he left some gaps in his periodic table, right? If you see, he has left particular gaps in his periodic table somewhere. Actually, this gallium and germanium, some of them were not even there. To be honest, they were not there. Gallium, germanium, okay, they were not even there. Even arsenic was not there. So if you see, these were some things which were not even there at that time, right? Even scandium, I believe, was not there. Okay, so this was a basic form of his periodic table, right? Now, what are the achievements of his periodic table? Let us have a look at the achievements of Mendeleev's table. Now, till now, whenever we have done some classification, we have only looked at the drawbacks. But here, this is so phenomenal that we even have to look at the achievements, okay? Number 1, the first and foremost achievement was that he left gaps. Why the hell did he leave gaps? Well, he left gaps because he predicted the properties of elements that could be discovered in the future. That could be discovered in the future. So basically he left gaps because he felt that these gaps could be filled up by properties, by elements of this properties, and he even presumed and predicted those properties, okay, as he predicted properties of, these are properties, okay, properties of elements that could be discovered in the future. And when they were actually discovered, which they were, the beauty was that, well, when they were discovered, they were just almost exactly the same as Mendeleev predicted, right? And that's phenomenal because that's really, really difficult. Still, he did it. And the gaps were filled with elements which were discovered. Examples were gallium, okay, germanium, these are 2 examples. Okay, there are more as well, right? So you can see that how well presented, how well he could actually, how well he knew his stuff, right? And that's just phenomenal. That's the first big achievement. The second achievement was that After discovery of noble gases, after discovery of noble gases, after discovery of noble gases, he was able to modify his table, able to modify his table without affecting its original structure. Without affecting its original structure. So when noble gases were discovered, which were discovered after his table, he was able to put them in a separate group, which is not mentioned as such here. He was able to put them in a separate group, and that, did not at all affect the main body of the periodic table. And that's just phenomenal. So beautiful. So well written. And it just shows the skill Mendeleev possessed, right? So that's again a good one, right? Number 3. He, found out some elements, right? And he put lanthanides and actinides. Okay, he found out a particular element, lanthanides and actinides, and he put them at the bottom of his table. So he put elements called lanthanides and actinides at the bottom of his table. And basically, they were continuations of the elements of lanthanum and actinum. These are two elements, and they were basically the continuation of these elements. Okay, lanthanum and actinum. And he put them at the bottom of his table, very, very cleverly predicting that there was some reason that they had different properties as compared to the main body of the table. And hence, although he could not give a proper reason for it, but still he put them at the bottom of his table, and that showed how skillful he was and how far-sighted he was. Although he did not give a proper reason, but he still predicted that their properties would be different as compared to the general other elements, right? And these are some 3 of the very, very important achievements of Mendeleev's table. Okay, another achievement was that his arrangement of elements was so beautiful and was done in such a way that element properties were repeated always. Okay, even if he had to violate the periodic law for that. So if you see here, cobalt and nickel. Here cobalt has a higher atomic mass than nickel, like 58.93 is greater than 58.71. But still cobalt is coming before nickel. Why? Because to make sure that the element periodic function remains same, remains constant. It is going with the flow. That the periodicity of elements does not change. The repetition in the properties of elements by a particular pattern does not change. Although this also was a drawback because he violated his law sometimes. But still, it showed the skillfulness he had, because he accordingly arranged, accordingly changed his law, accordingly flexible, made his law more flexible so as to make sure that that periodicity of elements does not leave out, right? So these were some of the very, very important achievements of Mendeleev's table. It was one of the most flawless tables at that time, although later on problems were discovered, but still, this is just phenomenal. Okay, so I hope this is absolutely clear, Mendeleev's periodic table and its achievements. Okay, now once we are done with the sweet stuff, we need to go to the bitter stuff, and now we come to the drawbacks of this table. Okay, we come to the drawbacks of this table. The first drawback, which is still a problem in the modern periodic table also, and that is the position of hydrogen. Position of hydrogen. Now, position of hydrogen. Hydrogen, basically, if you look at hydrogen, hydrogen has an atomic number of 1. So its electronic configuration just has 1 electron, right? Now, there are 2 things which can happen with this hydrogen. Either it can lose 1 electron and form H+, which is a hydrogen ion, right? Or in the same way, not with not much of a difference, it can even gain an electron and form H minus, which is a hydride ion. So it can even lose electrons and it can even gain electrons, right? If you look into the table, hydrogen, it should be placed with lithium, sodium, potassium because it can lose one electron, just like all of these. Lithium can lose one electron to form lithium plus, sodium can lose one electron to form sodium plus, potassium one electron, potassium plus, and so on. But it can also be placed in group 7 with fluorine, chlorine, bromine, iodine, because fluorine gains one electron to form fluorine minus, chlorine gains one electron to form chlorine minus, bromine gains one electron to form bromine minus, iodine gains one electron to form iodine minus. So if you see here, what do you see? You notice one thing, and that is that if you look into the property of hydrogen, it can even lose one electron or it can even gain one electron. Therefore, hydrogen can be placed in either the group 1 elements or even group 7 elements, that is halogens. And group 1 is called your alkali metals. Right? So it can be placed in either of these. So there is an ambiguity in the position of hydrogen. And Mendeleev was not able to, solve this dilemma by giving a proper position for hydrogen. Right? And hence, this was one of the biggest problems of his table. And it is still a problem in the modern periodic table, which we will discuss during the modern periodic table. The second problem with Mendeleev's table was isotopes. Position of isotopes. Okay, position of isotopes. Now, position of isotopes. Now, you know what are isotopes? You've done this in class 9th. Isotopes are basically atoms. Okay, atoms with the same atomic number. But different atomic mass. Now, you know that Mendeleev's table was based on atomic mass. Now, isotopes are those atoms which have different atomic masses, although they have the same atomic number. So, for example, carbon 12, carbon 13, carbon 14. Right? Now, all three are isotopes, but they have different masses. So, if you see here, all three are carbon, but they have different masses. But Mendeleev's table was based on mass, right? So, that meant that Mendeleev had to give specific positions to specific isotopes of an element, right? But did he do that? No, he did not. So that was another major drawback of his table, that isotope position could not be determined because isotopes have same atomic number but different atomic masses. And since Mendeleev's table was based on the uniqueness of atomic mass, every isotope should get its unique position. But that was not the case. Not every element got a unique position for an isotope, right? So that was another problem of Mendeleev's table. The third problem which we can discuss, which is a minor problem, was that he left gaps. So although that proved to be a correct method because his prediction was brilliant, but still it showed a bit of emptiness in his table. So again, that leaving of gaps was to some extent a drawback. Next is that he violated periodic law at times. Periodic law of increasing mass at times. So at times he basically, violated his own law that we have to arrange them in increasing order of their mass, like the example of cobalt and nickel, which is pretty clear and I've explained it to you. Cobalt 58.93, nickel 58.71, but cobalt is being placed before nickel, even though it has a higher mass. So although again this is an achievement because it was brilliantly done to ensure the periodicity of properties, but still he violated that law, and to some extent it was a problem, right? So these are four of some of the important things. And fifth one, which is not there in your course, but since I've mentioned it before, I'll tell you again. He did not give a reason. He did not give a reason. Give a reason for position of lanthanides and actinides. Position of lanthanides and actinides. So you just place them at the bottom of his table, saying that they were continuations of the elements lanthanum and actinum, but still there was no proper explanation given as to why they have to be kept separate, although they have different properties, but he did not give an explanation for that, right? And that is based on your orbitals, subshells. So I'm not going to go into much of detail for that. So he did not give a reason for the position of these, right? Again, that was a drawback of his periodic table. Right? So I hope that's absolutely clear. Out of these two are the most important drawbacks. You should name and be able to explain these drawbacks. They are very, very important drawbacks, right? So that's pretty much it with Mendeleev's periodic table. And with this, we are done with the classical concepts of periodic table, right? So in the next concept, in the next chapter, in the next video, sorry, next video, we will be discussing about the modern concepts of the periodic classification. So I hope that's absolutely clear. All of the classical concepts are clear. If there is any kind of doubt, please leave them in the comment section below. Please like, subscribe, and do keep studying. Bye-bye.